Good afternoon, dear students. Welcome back to Data Structures and Algorithms class. In the last class, we had discussions regarding introduction to C and who developed what is constant. And today we'll discuss some more components. Okay. Let us have a small review of what we have discussed last class. Last class we discussed about the brief history of C and some of the key features of C language. And we discussed why C language, what is the use of C language, and we discussed about all these contents, its properties. Then we discussed various modes of executing a C program. So online mode, we can run how exactly without compiler, how exactly we can run, and what are the different parts of the program that we discussed. So that's about the previous class. And we also discussed about the tokens. What is a token? Token is actually the smallest unit in a program. We call it as a token, and we discussed that. And we also discussed what is constant and different types of constants, how to create constants, 3 ways of creating a constant we discussed, and example for each one. So we discussed about all these 3, and now in today's class we'll talk about variables. So as you know, variable is actually a name given to a set of data storage for the sake of execution, for the sake of storing some data, and it is used for execution. When you use variable, we actually refer to the address of the memory, and this address that always points to the data where it is stored. And C language supports 2 types of variables, as you know very well. So the first one is numeric variables that can store number values, and the other one, the character variables that can store only characters. So apart from this, variables with numbers, you can see integer is a number, float is a number, double is a number. So you can see these are the 3 examples that talks about the number variables, numeric variables. Next one, we have character variable which can store a single character. And of course, all these things we'll be using in our further discussions. We'll be using in our further discussions. So moving further, different rules for giving names to variables. We call it as variable naming conventions, naming rules. What rules we need to follow while giving the names. So here, first rule says the variable name should be only alphanumeric, and it should start with only alphabets. Alphanumeric means it can have the uppercase and lowercase characters plus numbers, but starting letter should be, the first letter should be always a letter or a character, alphabet. It can have number later. The numeric value later in the next part. But alpha numeric it can have, but it should start with alphabets or underscore. It can have underscore. Second. And third point, very interesting. There is no rule on how long the variable should be, how much long you can give. But however, you may run some problems if you give beyond 31 characters, name beyond 31 characters. Their compiler may give some problems. So always give the variable names meaningfully, that have meaning to it. And of course, the last point, the reserve words or the keywords cannot be used as variable names. If you use, what happens? You will get errors. That's it. You'll get errors if you use it. So that's the takeaway. And here is some simple program which I have taken from your textbook. So from your textbook, page number, page number 13, I have taken this textbook. From your textbook, I have taken this program. What does this program indicates? Okay, you are importing stdio.h, that is, you are including a header file. You are creating a constant CP, its value is 50. That is, this type of constants, we call it as symbolic constants. So those who have book and pen, I told in my class, everybody you should have book and pen, and you should write down every class. Please write down whatever it comes on the slide, please write it down. Okay. As you write, as you listen, it will stay longer in your memory. Right. And right. I was just talking about the constant. We have created a constant called CP. Its value is 50. Its value is 50. And I'm declaring inside the main, I'm creating a variable called SP, that is selling price of 70. This is where you are declaring SP as integer, and its value also you are giving it as 70. Now, profit is equal to selling price minus cost price. You're just doing some operation, and you're trying to find profit. The same profit, whatever you have stored here, you're displaying using this. You're displaying using this, and finally you're returning the value. So this is what you can see, and of course the same thing I can say. You can see. One second. Yeah. Same program I have already typed and kept it ready for you. So it is there in this particular link. That link I'll be just posting in your chat box. Just click on that particular link. It can take you to a place, a page where I have typed the same program. So you can just scroll down and run. Yes. So when you run, you get the profit is equal to 20. That is the output you are getting. So here is the output. Profit is equal to 20. That is the output that you are getting. So you can see explanation I have given previously, and this program you can run it straight away. Those who are there in the laptop, those who are using desktops, I always recommend you to attend the class using laptop or desktop. Never take my class unless it is emergency. Never attend my class, never take my class in mobile phone. Okay, because a lot of exercises you can do, lot of exercises you can certainly do it. So coming back to our slide, right? Okay, this is a simple exercise that we did. We explained the program and I gave the link where you can run the program. You need not have to type, just it's an hands-on experience. But all these programs you should practice at home. You should practice at home. You should start writing a lot of programs, such programs, and you should remember these programs, how these programs are working. In the examination, in the test, if a question comes, you are supposed to write it down on the paper, right there. So, and next slide talks about what we call it as the keywords or reserved words. So, keywords or reserved words, they have already predefined meaning, fixed meaning, which is written inside your compiler itself. So, we can use it as and when we need to use that in our program, we can use it, but it's not. Now, after this, there are data types. Data types. So the data, whatever we are storing in variables, whatever we are storing in constants, will have different types. So there are three types of data types. So in C program, there are three types of data types. Please note down, those who are noting. I want everybody, all 55 students to write down. I want all 55 students to write down this diagram. So the first one is primary data type. This is also called as the basic data types. In some books, it is written as basic data types. The primary data types. What are primary data types? There are four primary data types: char, float, int, and void. Void is nothing but, so if you want to store empty value, it's void. And integer, yeah, a rounded number, if you want to store, yes, it's an integer. Integer has so much variations. Short integer or just integer, long integer, if you want to store very long number, and unsigned integer, only positive numbers you want to store, and long integers, unsigned long integers, short integers, unsigned short integers. There are so many integers types variations. You can certainly use it as and when they are required. Right. Next, if you want to store real numbers means the fractional values, 23.5, 9.8, scientific values. So you can certainly use either floats. You can use. Suppose this floating number, if you want to store the scientific exponential values, 3 into 10 raised power of 8, the speed of the light. So if you want to store, definitely you can use double. You can use double for a longer, bigger number or a very small number. So double, long double, yes. Long double is very big number, especially during scientific calculations. We certainly use this. So that's the thing. And character. Character, normally it is a single character that can hold only one character or multiple set of characters. Anyhow, we'll discuss that. I'll come to user-defined data types later. Derived data types. Derived data types are derived from primary data types. They are created from the primary data types. What are those? Pointers. We'll discuss this in detail. Pointers. Arrays also we'll discuss in detail in the next upcoming week. Structures, unions. We'll discuss all these things in the upcoming classes. Apart from this, user also can create his own data type. He can create his own data type. So using the enum, he can create enum. We have seen this while creating constants. Yes, exactly right. During constants, we used enum. Enumeration is called enumeration. The entire process, we call it as enumeration. The same enumeration, you can use it for creating user-defined data types. And there is one more method, we call it as type def. Type def is another kind of thing where we can create our own data type. We can define a new data type. You can create a data type on your name. Yes, you can create a data type. So these are the different ways in which you can have the data types, various data types in C language. And of course, very popular, the data types. Each data type has its own capacity to store data, And of course, uh, we'll check what are these data type, you know, capacities. Look at there. Short integer takes only 2 bytes of memory, and it ranges from this. And you can certainly use short as a percentage HD and unsigned uh, percentage HU and unsigned. See, signed and unsigned. Signed is actually 32,768 to 767, 32 minus 2 plus. But if you say signed, only positive numbers 0 to 65,535. Same way, unsigned integer will take 4 bytes. And of course, it depends again. This memory, it again depends on the type of compiler that you are using, type of operating system that you are using, type of machine that you are using. But according to ANSI standards, ANSI, I have told in the beginning itself, American National Standard Institute, ANSI C standards. So this is the table. This is the table that you should always remember. In the interviews also, if any question comes out of this, so you always refer to ANSI table, ANSI specified C language standards, you can certainly use it. So integer and their ranges and of course their symbols. So you can certainly take this and remember one thing. I know all these things you cannot write it straight away, but you can take screenshot and later for your reference you can write it. You can certainly write it. So that's a very important thing that you should note. And long double takes 12 bytes of memory. It can store very long data. And the format specifier is percentage capital L small f. Small lf is for double. Small f percentage f is for float. So you can see all these what we call it as specifiers are very, very important. When we are printing it, they are very, very important. So it definitely helps you a lot. So that's what I want to give you at this stage. So you should know all these things. So you have already studied CCP in the first semester. Of course, this is again a continuation of it. This is again a continuation of it. So you should never forget, right? And moving further, the same thing. It has been specified here, which is normal size and their control strings. But remember, note, the size and range of integer, short, long are compiler dependent. size in the figure are given for 16-bit compiler. Again, compiler, it depends upon your operating system. Your operating system, whether it is a 16-bit operating system or 32-bit operating system. Or sometimes operating systems have come with 64-bit. So if I'm using Windows 10, i7 processor, definitely it is a 64-bit operating system. So in that also, if I can run a C program, of course, there may not be same. There may not be same. It may vary, but whatever I have shown here is an ANSI standard, ANSI C standard. So normally this will be taken as the standard for specifying the data size, data type sizes, and their ranges. So that is the reason I have given. I given in the notes also, probably after completing this entire chapter discussion. So definitely we will have to give notes, and in the notes I have specified that also. Now, moving further, we have input-output system. Before we write actual programs, how to read data, how to write data. It's very, very important. Very, very important. Read data and write data. So there are two ways in which you can read data and write data. One is formatted input-output statements. Formatted input-output statements. Formatted functions, we call it as. What do you mean by formatted? So you have seen in the previous slide, the format specifiers, %D, %C, %S, %L, %F, %LD, %LF. So those are called control strings. If you write the format specifiers within double quotes, they are called control strings. If you use control strings, then either you have to use scanf or printf. Yes. For character, you can use scanf or printf. Yes, it works. Same way for integers, scanf, printf. Yes, it works. For float, scanf or printf. Yes, it works. For string is nothing but name, collection of characters, a group of characters, you call it as a string. Anyhow, we'll discuss that in upcoming class. Of course, for string also, we can have scanf and printf. Certainly, we can use it. So, if you use scanf and printf to read and display data using control specifiers, format specifiers, that is %D, %C for character, %F for float, %S for string, S for string. So then they are called formatted functions, because you have a format, specific format. You have a specific format to read and write data. So scanf and printf are formatted statements. Okay. Next comes unformatted functions. Unformatted functions. In unformatted functions, what happens? There is no format specifier at all. And remember one thing, this unformatted functions will not work for integers, will not work for floats. Numbers, it will not work at all. For numbers, it will not work at all. It will work only on characters or a group of characters. I have said string. Group of characters, you call it as a string. Okay, suppose I want to read a name. Yes, get s. I want to display a name. Put s. Okay, name is a set of characters. It's a string. So string-based operations, if you want to do, then you can use getS and putS. Of course, there is no format specifier. So here, no format specifiers, no format specifiers, FS, I write. Format specifiers are not there. No format specifiers are there. So, and it will work for character, yes, fantastically. It will work for strings, yes. So get ch, put ch, get che, put char, get char. Remember, get char is to read a character. Put char is to just display the character on the screen. Display the character on the screen. Now, what is get ch and get che does? See, the difference between get che and get char, or get ch or che and get char, is that after reading the character, you have to press enter key. In the case of get char. In the case of get char, suppose enter your section. You write A section A, and after that you have to press enter. In the case of get char, you have to press enter. That is, you need to press enter key. So you need to press enter key in the case of get char. That means until you press enter key, whatever the input that you have typed in, it will be stored in a temporary memory of your keyboard called buffer. So once you press enter key, from the buffer, it goes for further processing. Okay, that is get char. So it is a buffered, unformatted input statement. Why it is called buffered? Because whatever the character that you are typing, it will be there in the buffer. Once you press enter, then only it goes to the CPU. Where is this buffer? Buffer is present on the keyboard. That's the thing. Next, what about get che and get ch? Very simple. They will never store in the buffer. As you type A will directly go and store in the memory, CPU memory. It will directly go and store in CPU memory. You need not have to press enter key after giving the input. After giving the input, you need not have to give any enter key. Directly it goes and stores. That's why they are called get ch and get che. They are called unbuffered, unformatted input statements. Unbuffered. Why it is unbuffered? It will never use keyboard buffer memory. Directly store it into CPU memory, the value, finish. What is the difference? CH and CHE? Get CH and get CHE. After you press the character, it will be displayed. In the case of CHE, echo. The last E says, this E says it is echo. Get CHE, E says it is echoing. That means it is displaying on the monitor. Whatever the input that you are giving, it will be displayed on the monitor. In the case of get CH, that echo will not display. That means that character, whatever the character that you are typing, it will not display. Sir, then where get CH is used? Very simple. When you are typing the password, can you see the password? No. You cannot see the password. But whatever you are typing, that will directly go to the variable that is there in the memory. Yes, in such cases, get CH is used. So get CH. It is used to read passwords. Anyhow, that is higher part of your discussion. Get CHE, whatever you are typing, that will be displayed. Get CH, that will not display. Next class, I'll show you one example. Usage of get CH and get CHE and get char. Get char, you have to press enter and put S to display, and of course, get S to read the string. Now, Let us look into one simple difference between getChar and scanf. See, since getChar is unformatted, there is no format specifier. Directly, whatever the character that you enter, that will go and store in A. Whereas in the case of a scanf, you have to give the format. First character, first input, whatever you are taking is a %d. %d means it is an integer. Second one, whatever you are reading, it is a floating number. Yes, it is f. That means x is of integer and t is a variable which is of float type. See, clear differentiation of data types is possible with formatted input statements. For unformatted input statements, integers and numbers are not at all in the picture. It will only handle characters. That's it. It will handle only characters. So that is the thing. Similarly, we have a simple example. This is example to demonstrate input and output functions. Look at here. Of course, the same program, I'll give you the link in the chat box. You can click, you will get that. So here what you're doing, you're reading the name. Here first you are declaring three variables. Age, marks, age is integer, marks is average marks is float, and name is a character of 10 character size. So you are reading the name, %s, name, you are reading, age, you are reading, and age is integer, %d. You can look at there, this %d. Yeah. After reading name and age, what you are doing, you are reading the marks. Marks is a floating number. So why every time before scanf you are giving printf? Because user has to come to know, right, what he has to enter, whether he has to enter age value or marks value or name value. What is that he wants to enter? So just to tell the user what he has to enter, so you are giving printf statement. And after giving printf statement, you are reading scanf. Every time you observe %f for float, %d here it is for %d here for integer, and %s for string. So you should always observe that there is a change. And here %f is a float. And after reading, all these values store in the variables, and from the variables you're displaying. While displaying also, %s is name, %d is nothing but age, %f in between something is there, modifier, %2f. That means if you have given more decimal values, it will take only after point, only 2 decimals. Only 2 decimals are taken. So this program link I'll be just giving to you. So it is there. I have already created. So you can just take this link. I'll put it in the chat box. Okay. Those who are not typed your USN for the attendance sake, please type your name. If you are not typed, please type your name for USN for the attendance sake. And I have typed I have given the link. You can see just now I have given the link. Okay, just click on the link. It will take you to the program where the same program, whichever I have demonstrating, the same program. So you give the name, first input you give. First input I am giving Satish. It is my first input. Second input my age 19. Third input I am giving my average marks 56 point. I'll just give 4567. But it will display only 2 digits because I have given only %.2f. That means after point, only 2 digits, 2 decimals are displayed. So run it. As you run it, you can see at the bottom, you will get the output. Student name, yeah, Satish. And student age, 19. And marks, average marks, 4.6. Even though I give more. So this is actually the static program. But if I run the same program using Turbo C, so I have Turbo C++. I can run, of course, in the Turbo C++ also I can run it. Okay. So as I run in Turbo C++, after displaying enter user's name, it will ask, it will pause for a while, and it will ask your name, and you have to enter. Okay, I just open the file name, open the file. So it is there in bin, yeah, ds2, yeah, the same program, yes. So look at there. I run this program. As soon as I run this program, it is asking enter student's name. I give Satish. Next, age 19, 56.1234. Even though I give more, it will display. Look at their output screen. I'll go to output screen. It will display only 56.12. Okay. So this is how the program, it will execute, and of course this program you can also execute. You have already copied the link, this link. So putting that link, you will get the program. Okay. That's all for today's class. In the next class, we'll be discussing about operators and expressions. Thank you. All the class recordings are available in my website. You can check it out. If you have missed anything, it is there in the website. You can get it. Okay. Thank you very much for attending my class. Tomorrow at the same time, we'll join. Those who are not entered your USN, please enter it for the attendance sake. Thank you.